All right, let's just dive right into this explainer. The next time you're outside on a clear night, I want you to look up at the stars and realize you are staring straight into a massive, eerie contradiction. Think about it. On one hand, we've got the infinite scale of the cosmos, right? Billions of galaxies, literally trillions of planets, and a universe that's been cooking for nearly 14 billion years. By all accounts, space should be absolutely teeming with spaceships, mega engineering projects, and the buzzing radio chatter of advanced civilizations. And yet, when we actually look up and listen, absolute dead silence. Nothing. It is the ultimate cosmic detective story, and today we're going to sort through the evidence to see if we can finally solve it. This entire mystery really kicks off with one incredibly simple but totally devastating question. Picture this. The year is 1950. The brilliant physicist Enrico Fermi is just sitting at a lunch table at the Los Alamos National Lab, shooting the breeze with his colleagues about a newspaper cartoon featuring aliens. And suddenly, Fermi just does some quick mental math. Factoring in how ancient the galaxy is and how long it would take a spacefaring civilization to spread out, he just stops, looks up, and asks, "Where is everybody?" It's the question that sparked this whole hunt, because the math behind it is just staggering. 400 billion. That's not just a big number. That is the impossible scale of our Milky Way galaxy alone. And thanks to modern astronomy, we now know for a fact that planets are the rule, not the exception. We're talking trillions of planets just in our local galactic neighborhood, with billions of them sitting right in the habitable zones of your stars. Even if you assume interstellar travel is incredibly slow, I mean agonizingly slow, a civilization with just a few million years of a head start could have colonized the entire galaxy by now. And yet, we have zero evidence, not a single trace. So if the galaxy is so crowded, who are our usual suspects for all this silence? Well, you've probably heard a few of these. A super popular one is the dark forest theory. This is that terrifying idea that expanding civilizations are inherently hostile, so everyone else is deliberately hiding their signals just to survive. Basically, don't shout in a dark forest. Then you've got the zoo hypothesis, suggesting aliens are definitely out there, but they're intentionally observing us from afar without interfering, kind of like zookeepers. Or maybe more practically, our search methods are just totally outdated. We've spent decades listening for radio waves, but an advanced society might have moved on to lasers and fiber optics ages ago. We might literally be the equivalent of someone listening for a telegraph message on a smartphone. But there's always that darker suspect. It's often called the Great Filter. As the legendary Carl Sagan pointed out, maybe the silence is there because intelligent life inevitably self-destructs. The theory goes that any species smart enough to build a global civilization will eventually unlock the technology to destroy it, whether that's through nuclear weapons, climate collapse, or runaway artificial intelligence. In this model, the galaxy is just a graveyard of fallen empires that basically struck a match in a room full of gasoline. It's a pretty grim warning that our hardest test as a species is still ahead of us. Part 1. The twist, the middle filter. To really get this twist, we kind of have to completely rethink how we look at planets. We have this habit of thinking that if a planet is in the habitable zone, it's just going to be habitable forever. But that is dangerously misleading. Habitability isn't a permanent state. It's a process. It's a phase. We call it a habitable window. This is a finite temporary interval that relies on a ridiculously delicate balance. You need a strong magnetic field, a thick atmosphere, active tectonics, and a stable star. Every single one of those factors is temporary, which means this window often closes way, way before anything complex ever has the time to evolve. I mean, just look at our two closest neighbors. They are the perfect, tragic examples of this window slamming shut. Billions of years ago, Mars had rivers and lakes, but it ended up being a cold failure. It was just too small, its core cooled off, its magnetic dynamo shut down, and the solar wind literally stripped its atmosphere away into deep space. On the flip side, Venus is our hot failure. It was Earth-sized, might have had oceans for billions of years, but a massive global volcanic event pumped way too much carbon dioxide into the air. It triggered a runaway greenhouse effect that literally boiled its oceans dry. Both planets had a window. Both windows slammed shut. Let's bring that Mars failure to life for a second. Think about Jezero Crater, an ancient Martian lakebed. The Perseverance rover has been driving around there and found fascinating mineral patterns, which might actually be biosignatures of ancient microbes. Now, whether these are officially confirmed as life or not, they highlight a haunting reality. If microbes did live there, they didn't die because they invented nukes or made some technological mistake. They died because they lived on a world that was slowly evaporating. Their magnetic shield weakened, the atmospheric pressure dropped, and their homes slowly became hostile. They just ran out of time. Part 2. Red Dwarfs, a Cosmic Trap. If you're sitting there thinking Earth-like planets around Sun-like stars are the standard, get ready for a bit of a cosmic bait-and-switch. Roughly 75%, 3/4, of the stars in our galaxy are actually red dwarfs. These are small, cool, dim stars, but they burn for trillions of years. And initially, scientists were absolutely thrilled about this. They thought red dwarfs were a gold mine for biology because their insane lifespans would give planets tens of billions of years to slowly evolve complex life. It seemed like a sure thing. But the actual physics of red dwarfs? They are absolutely ruthless. Because these stars are so dim, a planet has to orbit incredibly close just to be warm enough for liquid water. And this extreme proximity causes something called tidal locking. This means one side of the planet is permanently baking as it faces the star, while the other side freezes in an eternal night. To make matters worse, young red dwarfs are violently active. They unleash these relentless superflares, constantly blasting nearby planets with intense X-ray and ultraviolet radiation. Over hundreds of millions of years, this stellar wind just mercilessly strips the planets of the atmospheres they need for life. The window has blown completely shut before it ever really opens. And we actually have sobering proof of this right now thanks to the James Webb Space Telescope. You might remember the TRAPPIST-1 system, a red dwarf orbited by 7 Earth-sized rocky planets. It was hyped up as our absolute best candidate for finding habitable worlds. But the JWST data revealed a really harsh truth. The innermost planets show absolutely no signs of thick atmospheres. None. They're just bare rocks baking in the dark. So these supposedly promising habitable zones around the galaxy's most common stars, yeah, they're actually cosmic dead zones. Part 3. Earth's ticking clock. So, if red dwarfs are a trap, and planets like Mars and Venus just failed, we really need to look in the mirror at our own world. Do you know it took our planet 3 billion years to evolve from simple, single-celled microbes to complex, multicellular life? 3 billion years. We are insanely lucky. Our planetary core somehow stayed hot enough to keep generating a magnetic field. Our tectonic plates kept recycling carbon to regulate the climate. Our sun was just remarkably well behaved. We enjoyed billions of uninterrupted years of stability. Human intelligence didn't even show up until the absolute tiny fraction of the last % of geological time. But here is the thing. Even Earth's window isn't permanent. And spoiler alert, it isn't human civilization that's going to ultimately close it. It's an unavoidable geological process. Just like all main sequence stars, our sun is steadily getting brighter and hotter as it ages. As it pumps out more heat, Earth's planetary thermostat, which is called the carbonate-silicate cycle, is going to have to work overtime to compensate. It'll start pulling more and more carbon dioxide out of the atmosphere just to keep the planet cool. Eventually, CO2 levels are going to drop so low that plants physically won't be able to perform photosynthesis anymore. And then the plants die, the entire global food web collapses with them. When you actually map out the timeline, it's pretty terrifying. In about 500 million years, C3 plants, which make up most of our trees and crops today, will die off. In roughly 1 billion years, the tougher C4 plants will go extinct. And the complex food web will be entirely gone, leaving nothing but microbes behind. Fast forward 1.5 to 2 billion years from now, and temperatures will climb so high that our oceans will literally begin evaporating into space. Earth is going to become a hot, desiccated world exactly like Venus is today. Our window will close for good. So, this whole cosmic detective story, it concludes with a pretty staggering realization. The true culprit behind the Fermi Paradox isn't necessarily that advanced civilizations inevitably destroy themselves. The culprit is time itself. The galaxy is probably teeming with life right now, but it's almost certainly just microbial life, stuck on worlds whose habitable windows are going to slam shut before complexity can ever take hold. That silence we hear when we look up at the sky, it isn't the sound of fallen empires. We are looking out into a vast graveyard of expired biospheres, worlds that simply ran out of time. Which brings us to one final, really provocative question. Think about it. If the transition from basic, simple chemistry all the way to an advanced civilization requires billions of years of absolute perfect planetary luck, a continuous window that somehow avoids the fate of Mars, Venus, and that nasty red dwarf trap, then we are the incredible exception. We aren't just the guaranteed outcome of a universe that's designed for life. We are the improbable survivors of a process that almost always fails. It completely reframes our existence as this fleeting, incredibly lucky spark of consciousness. And knowing just how rare and fragile this window is, well, it tells us exactly how urgently we need to protect it.